Something like that. It happens sometimes. But most of the time it looks like this. This is our campus. You can probably see in the upper right-hand corner a little body of water that's actually part of the Mississippi River. And St. Paul is actually to the back out of the picture, Minneapolis a little farther in the distance. We actually have campus both on St. Paul and the Minneapolis side. And I live on the St. Paul side. You might also think of this when you think of Minnesota. How many have seen this movie? Beware, though, where is Fargo? North Dakota. So people associate this movie with Minnesota quite a bit, but interestingly, the title comes from a different state. So go Google it sometime. You can get into all that. The exciting thing, though, is the Coen brothers, who directed and produced this movie and many others, are from the suburbs of the Twin Cities. I might use a few strange words, foreign words in the Minnesotan vocabulary. So I listed a couple of these. I wanted to point out holy buckets. So when my wife swears as a native Minnesota, that's what she says. You might have all seen that there was an infographic that made its way around on doing an analysis, kind of a TF-IDF analysis of dating profiles. And the most significant word appearing in the dating profile of Minnesotans, but that's also rare across other states, so highly frequent in the state, but rare across the collection of states, is the word cabin. And I find when people hear the word cabin, they think like of Abraham Lincoln, log cabin, no indoor plumbing. Most of the rest of the world calls cabins vacation homes or second homes. And the reason people can afford a second home is because the housing cost is about $120 per square foot. So I actually checked for San Francisco what the equivalent was. It's like 7 or 8 times that. So you can buy 7 or 8 homes if you can afford a home in San Francisco, in Minnesota. So one of the first things I want to state is that you are not normal. And I mean this in a good way. You are not normal in the sense that if you are at this conference, it's because you already know something about Spark and Scala, at least enough to know that it's important to be here. And you are likely either familiar with these technologies or deeply involved with these technologies or already on the path to do so. But I'm interested in a little different problem. I'm interested in the problem of how do you take the masses to Scala as a language? How do you take the masses to Spark, especially if they come from a MapReduce background? I also have to address the question my classes are increasingly asking, which is, well, if the Spark Scala stuff is so hot, why are we doing the Java MapReduce stuff? And my answer is usually, well, when the technology changes, we invalidate your master's degree and you just have to come back for another one, right? So what I've got to do is tell them that the concepts we are dealing with are really the ones predominant in our Twin Cities market, where there isn't as much Spark mania as there is around here. And also to take comfort in a lot of those concepts will transfer to Spark and to Scala going forward. So I'm interested in groups of people where these might be some of their characteristics in their background. No undergraduate computer science degree. We see a lot of people that are changing careers, coming from fields like Latin and law and medicine in some cases, and are interested in software engineering. Maybe that's been a side project. Maybe that's they just decide to make a radical shift in their career. We're seeing an increasing number of international students, probably upwards of 40% now. Used to be, we had students from India and China pretty regularly. Students from Africa, students from the Middle East are a growing population. Often people do not have Linux experience coming into our program. They might have only recently learned to program but aren't very confident. Might have gone through a Java class but given a piece of paper and a problem, have no idea where to start. And if they do know a computer language, it's likely Java, it's likely only one language. And not only don't know Scala, they probably have not heard of Scala. They might not even have backgrounds in operating systems or architecture or data structures or algorithms, things that are important to think about, especially in these highly scalable systems that are determining performance and scale characteristics are so complex. They might be aspiring to their first job in IT, or they might already be working in a company, but one that's very conservative about their technology selection and forays into new technologies. I have students that program in COBOL. Right? So languages, one of the conclusions here is languages never die. Right? People still need Fortran and COBOL to some extent. And Scala is hard to the majority of students. Now there are certain students who you know, a week can learn all this without much direction. Those aren't the ones I'm worried about. The problem there is keeping them engaged and busy. I'm more interested in the problems I outline here. And you know, why don't we just say, well, go away until you learn all this stuff and have this background, come, you know, go get it somewhere else and come back when you have it. And one of the things we very much believe in is the power of education. For many of our students, having a master's in software engineering is literally life-changing. And our focus is applied. So we're not after the training side, which is important. Aspects of training are important because that'll help people get their internships or their first job. But we very much also want them to have some foundation in theory because that part of education can last them for decades. So Spark Mania, I used that term already. You know, where are we at with Spark? And you hear various things on here. You still need it for the biggest data. It's still a fact that traditional MapReduce is powering most of today's big data. But there's growing movement to the bottom right-hand side where people are viewing MapReduce as dead. Dead is probably too strong a word here. And long live Spark. And there's some technical reasons for this. One is just a fundamental technology trend about the decreasing cost of memory and increasing capacity. And we love to use fast memory, especially for these iterative algorithms that have arisen in areas like data mining and machine learning. But Spark is also very attractive because it's a much simpler API. It's more fun, it's easier to write those programs. But Spark Mania is not only a technical issue. One of the things I'm interested in are really some of the non-technical issues in programming languages and programming paradigms. Why do languages become popular? There are over 2,500 programming languages. Most of them go nowhere. Why do some bubble up? So here are some of the non-technical factors I think of. First, all the cool kids are doing it, so you got to jump on the bandwagon. If you're a startup and you need some glitter in your funding proposal, things like Scala and Spark can certainly provide that. Often startups can be free or at least freer from a lot of legacy constraints, so freer to use the latest technology. Spark certainly looks great on a resume, even better if you know something about it. It's important for recruiting and retention. These are hot and interesting technologies. There is a lot of industry investment in this area and certainly a lot of momentum. So, but most of the existing knowledge in big data is still on MapReduce and still Java. Most of the existing practitioners were brought up on these models. So the question, especially in an environment where, quote, everyone knows Java and, quote, no one knows Scala, how do we efficiently move people from point A to point B? And one way to answer this question is just say, well, that's really not the right question. Just have everybody program in SQL, and whatever the underlying engine is, it'll just work. So all you really need to do is teach people some SQL, and everything just magically happens underneath. Well, unfortunately, there is not only one SQL in big data. There are multiple. They have all different, not only some syntax differences, but operational characteristics that differ. And fundamentally, I'm a believer in the best way to be effective, whether you're a high-level language programmer, whether you're a database programmer programming at SQL, or even if you're using higher-level tools, the more you know about what's going on under the covers, the stronger you're going to be. The better you're going to be able to deal and anticipate and problem solve scale and performance issues. So Spark has an interesting profile of languages. beginning with Scala, Python, and Java bindings, more recently adding R and SQL to the mix. There was some data published earlier this year about the languages Spark programmers use, and a surprisingly number were using Scala, 88%. Java was in second, and Python was down pretty far. Now, earlier at this conference, I actually talked to the person involved in the study, and they said that this was not a data science community. This was a software development community that was polled here. So I would expect if we asked data science people, Python would probably pop up to the top here. But fundamentally, Spark is a nice API, and the idea of a functional language better matches what happens in these big data applications where you rely on parallelism. Problem for a university is, well, why don't we just start teaching Scala? And one way to try to answer that question is look at where the industry is at in terms of programming language popularity. So I'm going to flip through 3 charts. You're going to see different answers on different surveys, in part to make the point that this is a hard question to answer on how popular various languages are, but also show you that Scala isn't in the top 10 on any of these languages. So TIOBE index, often used to look at programming languages, especially over time. Scala is 33rd on the list. This was an IEEE Spectrum list that just came out recently. Scala not on the list of the top 10 languages. It's 19th on the list. And Codeval put out a survey. This is the highest it's been on any survey I've seen, 12th on the list. More interesting to me is there was a survey done of the top 39 computer science programs in the US, looking at the language that was used to teach programming at an introductory level. And Python showed up as number 1. I was a little surprised at this. I was a little surprised at MATLAB being rated so high. I wasn't so surprised at the C and the Java or the C++. The only functional language on there is Scheme. MIT was famous for introducing Scheme, believing that it's important to teach freshman computer science students how to program functionally before using an object-oriented or an imperative paradigm. But they even have moved to Python. And they have done so because computer science departments often feed other engineering and STEM programs that programming levels vary and different libraries are more interesting than others for certain domains. So that can push more toward the Python and MATLAB kinds of applications. So ideally, if somebody said, I was just stranded on a desert island and I'd like to learn how to do this Scala Spark stuff, I think this is the ideal if you're starting from a Java base. Spend years trying to learn Haskell, a pure functional programming language. The reason I say that is I think it's easier to be forced into a paradigm rather than be in a position with a multi-paradigm language and wonder whether you're doing it right or not. And Scala, you can say, well, I get my code to run, but is it really functional or not? Then spend a little time, weeks and months, going to Scala, and then a few weeks going to the Spark Scala API. More pragmatically, though, going from a Java base, I favor an approach where you spend days to weeks understanding the OO features of Scala, and then maybe weeks to months learning enough of the functional features in Scala to use Spark, most likely as a domain-specific language, and then enjoy the multi-year feast on all the intellectual richness behind full-blown functional programming. So I'm going to outline 4 stumbling blocks I commonly encounter with students who are trying to learn how to use Scala. One is the idea of functional programming, and your program doesn't run line by line by line. And I found it helpful to talk about Excel spreadsheets, which everybody knows how to use, and how spreadsheets are a model of computation, one where firing of functions feeding other functions conveys the functional paradigm. And it also can convey laziness and short-circuiting, and even introducing the notion of things like infinite streams. The second building block I run into, or stumbling block I run into, is, hey, what's the difference between val and var? And you start out by saying, well, just use vals, don't worry about vars. How many of you have a 3-year-old, like niece or nephew or kid, or have had one? All right, it's kind of like them asking you why the sky is blue. You give an explanation. Well, why is that? Well, why is that? And you enter the infinite regress of explanations, and pretty soon you're in quantum mechanics and explaining why the sky is blue. Although I used to at some point just say, ask your mother. Although I've heard that a more modern answer is, what, is the internet down? Can't you Google it? And there are good reasons for doing vals, and more importantly, using immutable state. Here are the benefits of immutable state and avoiding side effects, but these are not easy and obvious concepts to get across and understand. And increasingly, I answer a lot of these as just be a little patient and you'll see the value of doing all this stuff as time goes on. You might have seen this XKCD. Code written in Haskell is guaranteed to have no side effects, and the smart aleck answer is because no one will ever run it. Haskell is even less popular of a language than Scala. Another stumbling block, what's the difference between vals and defs? What's the difference between variables that can hold functions and methods of objects? So that takes a little time to digest and get used to. How many of you know what recursion is? Typically 10% of my class knows what recursion is. So spending some time talking about linear and tail recursion and getting them to identify the patterns in the forms and going through exactly what's happening on the stack and the scale issues is something we need to spend a lot of time on because so much of Scala and functional programming is recursion based. And also I find it helpful to start with a piece of code in the upper right, which is something that might look more familiar. This is a sum of squares in an imperative style in Java. This is Scalaized Java in the upper right. And then doing continuous refinement to show how you can transform it and be more functional. I also like talking about parallel collections because if you jump to the bottom there, it's kind of like MapReduce. Do a map and a sum is like MapReduce, so people kind of see these functional concepts relating to the MapReduce concepts they might know. I also like sharing with students my language opinions. Bjorn Strustrup, who created C++, said there are only two kinds of languages, the ones people complain about and the ones nobody uses. So I leave them with a list of things I like about Scala. And I leave them with some things that I don't like. Java 8 is one that worries a lot of people. I sometimes hear students say, well, Java 8 is out and it kind of does functional stuff, so does that mean we still have to use Scala or can we just use Java from now? And it's hard to convey to them that every Scala programmer that I have met, when you ask them about Java 8 and its functional capabilities, they say, yeah, interesting. I've not yet met one who is going to change, say, oh yeah, I don't need to use Scala anymore, I'll go back to Java. I've never met one in 2 years of asking that question. I also give students a little first cut at how you go from concepts in MapReduce to Spark. And notice there's some things in the column that you don't need to worry about at all, and other things that are new concepts that are only available in Spark. So this gives them some assurance that the concepts they've learned in MapReduce do carry over to Spark, and an initial guideline of where to look to take concepts they might know on the left and move it to the right. I also encourage a little different format of Spark and Scala code that you might be used to in exposing the RDDs and separating out input, output from the processing in the middle. And primarily I do that for its unit test capability. If you've used MRUnit, you've probably seen the nice JUnit-like unit testing environment. We're able to emphasize that. So in conclusion here, for many applications, the Spark Scala API is preferable. And it really won't take long for most Java programmers to become proficient enough in Scala to be able to attack Spark. And more importantly, I truly think Scala provides an intellectual feast that will last for years. And I'm going to go out on a limb here. I did this, the last time I did this was in 1995 when there was only one Java book on the shelf. I said, I think Java is going to be the next language. And I haven't had this feeling since 1995, but I think Scala will eventually become the predominant language. And notice I used enough soft words in this proclamation that I'm guaranteed to be right no matter what happens. So it's fun stuff. If you haven't used Spark and Scala together, jump in. Questions from anybody or comments on your own experiences? Yes.
Can I bring the mic to you?
Sure.
So your slide on journey to Scala, you kind of assume that people always start from Java.
Right.
And I think that's not completely right, because I have actually not started from Java. I don't program in Java. I've never programmed in Java professionally. I started from Haskell, and before that in C++. So that assumption that people will always start with Java, or why do you think that that is even a good starting point?
Okay. So one of my first slides says, "You are not normal," and you are not normal. I mean that in a good way. The C++ and Java backgrounds are interchangeable. Having some notion of a strongly typed language, statically typed language in a software development environment is very common. So Java and C++ are interchangeable there. The Haskell experience truly is unique. I can think of one student in 5 years that had any background in Haskell. So you're right. So the ideal journey would be to go to Haskell and then go to Scala. I actually thought you were going to say you were coming from a Python background, and which is very common for data science.
Yeah.
Again, I'm kind of addressing a software engineering body of students.
Yeah. Also, I think your survey, which says about functional programming languages, restricted to the US universities as well only. And I think if you will poll, if people poll more universities in Europe, you might find that Haskell is not that uncommon. And I did go to school in Europe, so Haskell was actually the first language that was taught to us. So.
Yes, good point. And I'm actually thinking about a sabbatical in a couple of years in Europe to look at functional language adoption there and how it differs from the US. So if you can catch me sometime in the conference, I'd like to learn from you. Other questions? All right, thank you.